All right, let's skip to number 9. I just wanted to show you a couple kind of special cases, or not necessarily special cases, but just to kind of tie in some of the things that we've done before, really. And so here I have a negative in front, so I definitely want to make that leading coefficient positive, so I'm going to factor out a negative. Then I want to check for a GCF, so I check between the 3, and the 216. Obviously, we have a 3 in common here and here, right? And since 3 is prime, I can't break it down anymore. And so I just want to check, does 3 go into 216? And it turns out that it does. It goes in 72 times. Okay. And so that means 3 is a common factor. So I can factor out a 3. And then they don't have a variable in common, so I'm just going to open up parentheses. And then I'm going to divide each of these by 3, right? Or by negative 3, I should say. So negative 3 divided by negative 3 is positive 1, so it'll be positive 1x squared. The 1 I'll leave invisible. 3 divided by negative 3 is negative 1xy. Leave that 1 invisible. And then 216 divided by negative 3 is negative 72y squared. All right, so what we have here now is we factored out this negative 3, and now we have a simple quadratic, right, or a simple trinomial. And so this makes life a lot easier, right? We don't have to do all the steps that we did when we were factoring complex trinomials. Okay, so that's one thing again about factoring out a GCF, is we go from having something that looks complex to something that is simple. Okay, so always check for the GCF first, because that can save you a lot of time and work and mistakes. All right, so here I'm just going to put a negative 3 here, open up my parentheses, put the x in front. I don't have to leave space because it's a simple trinomial. Put the y in the back. And now we're just looking for numbers we can multiply to get 72 that we can subtract to get 1, right? So numbers we can multiply to get 72 that we can subtract to get 1. So here, if you don't know, you can make yourself a list, right? Just like we did with when we have complex quadratics, and even before that, we did that with these. So 72 minus 1 is not 1, and so I have to keep going, right? Getting these closer together will get me closer to a difference of 1, right? So 2 does go in. 72 divided by 2 is 36. 72 divided by 3 is 24. 72 divided by 4 is 18. 72 divided by 5 doesn't work. 72 divided by 6 is 12. So we're getting closer, right? 12 minus 6 is 6. And so we're getting closer. So then 7 doesn't work. 8. 72 divided by 8 is 9. And ding, 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 we have our winner, right? And remember, that's as far as we could go. So we got lucky, because if we'd have tried 9, we'd realize, oh yeah, 9's on the other side. So this is the end of our list, right? And so, so anyway, that's our, those are our values. So we put the 8 and the 9 here. No need to do anything else, right? But you can see it does work, right? If this is an invisible 1, so I could put a 1 underneath here, right? And bring the 1 to the front, and it would work the same way. But no need to do that here, right? Because we know simple quadratics are simpler. And so this negative here is going to go in front of the bigger number. That's our bigger number. And this negative here tells us our signs are going to be different. So that means it's going to be positive. And that's it.